finding an equilibrium concentration using an ICE chart. So this is part of the equilibrium unit in chemistry or high school chemistry. So when you're looking at setting up an ICE chart based on these type of questions, there are 3 letters that we need to know. So I is the initial molar concentration. So we're looking for moles per liter. So if that's not given to us, we'll have to figure it out. C is a change based on the molar ratio. So here you definitely need a balanced equation. So if it's not given to you, we'll have to come up with it. And the last one, E, is your equilibrium molar concentrations. So again, this goes in moles per liter. So we'll need to figure that out sometimes. And this E is the line we use in the equilibrium expression. So depending on what we're given, we might have to use a Kc value to find something within, or we have enough information to find Kc. So we'll have a few different examples here. The first example I'm setting up is to figure out the equilibrium concentration. Then I'll do another video in a moment, and it will be calculating an initial concentration based on an ICE chart. So in this particular example, it says under certain conditions, Kc is 650. Initially, 50 liter gas tank contains 10 moles each of N2 and O2. And then we want to calculate the equilibrium concentration of NO. So before we begin, because it wasn't given to us, we will need to come up with our balanced chemical equation. So you have N2 plus O2. It is an equilibrium, so your arrow would go both ways, and that will give us NO. I'm not worrying too much about my states because I just need a quick equation to get the mole ratio. So before we move on, let's balance this. We'll need a 2 here, and then we can set up our ICE chart. Now, from here, again, I is initial concentration. So if there's 10 moles of each of these, then you would want to go 10 moles divided by 50 liters. So I'm just feel like I could have done that in my head, but just wanted to make sure, have my calculator out. This is 0.2 moles per liter. And then for oxygen, it would be the same thing, 0.2 moles per liter. And if there's no information about the product initially, you can make the assumption that there is none there. So they put these 2 gases into the container. We know how much we have, and initially we don't have any product yet unless it tells you otherwise. Then we get down to C, and C is a change, and it's based on the mole ratio. So reactants are used up. We have, if you don't see a number here, you can assume it's a 1. So we'll have minus X, because again, there's only 1. And then we'll have products. Products are being formed, so we'll add 2X here. Now we can come up with the E, and you're just adding the I and C together. So the equilibrium molar concentration of N2 would be 0.2 minus X. Same thing for oxygen. And then for our nitrogen monoxide, it is just 2X. Okay, so this is the line that we need, and it's usually the most important line depending on what we're calculating. And what we want to figure out is the equilibrium concentration of NO. So to do that, we need to solve for X using the equilibrium expression. And then once we have X, then we can just multiply it by 2, and we'll have the equilibrium concentration of NO. So I'm just going to come over here to set up. If you know what Kc is, and it's telling us it's 650, then we also know that the Kc expression is products over reactants. So it would be NO squared. That squared is coming from the 2 in front. And if you need a little bit of help with this, I do have a lesson posted on how to calculate the Kc expression. And then it's over reactants. So our reactants is concentration of N2 and our concentration of O2. So we have that. Now, all of this information we get from the E, so we can plug that in. We also know that Kc equals 650, so we can also plug that in. So I'm going to put 650 here, and that will equal 2X, and this value is squared. divided by, and this will end up being the same thing. So 0.2 minus x times 0.2 minus x. So just to simplify that, I'm going to be putting 0.2 minus x. Because it's just multiplied by itself, I'll put a squared here. So now we've set it up. So the next part is to find x, or solve for x. So to do that, hopefully your math skills are strong. If you're unsure what to do at this point, you want to square root both sides. That will get that squared to cancel. And at the same time, we'll multiply this denominator up. So you're going to have, I'm just going to show the work here. We'll get a little bit messy. Root 650, and we're going to multiply this by 0.2 minus x, and that will equal 2x. So you can go ahead and use your calculator and multiply that root 650 through, and try not to round too early because that will affect your answer. So I'm just putting this into my calculator, and I get over here from my first calculation, I will get 5.099, and I'll keep that value in my calculator. And then it will be minus, and then the root of 650 minus x was 25.49. Again, we'll keep those decimals in the calculator, and then x belongs with that. And that will equal 2x. So let's collect our x's on one side. So let's add that 25.49x to both sides. And we'll simplify this again. So we just want to add that together. So 2x plus 25.49x will give us 27.49, and that decimal will still be there, x, and all of that will equal, because that will go away, this value here, which is getting squish, 5.099, and that value is still in my calculator. So let's get x alone, divide both sides by that 27.49. Again, the decimals are in my calculator, so I'm going to get that alone. And let's put that on in there. I'm just going to do that quickly. So that 5.099 divided by 20, I'm just going to take that value, plus 2. And I can see my value for x equals 0.185, and that value is going to keep on going. So now that I've solved for x, this is the easier part. Now I can plug it in. And if they could have asked any one of these concentrations, but it's asking in particular the NO. So I'll take that value for x, plug it in, and multiply it by 2. And you will be able to see that your answer is going to be C. You will get 0.37 once you have done your sig digs. So I hope that one is helpful to find an equilibrium concentration. If you have any other questions, please let me know in the comments. If you needed to see a different type of video, please let me know in the comments. I hope this helps. Have a good day. Bye. Oops. There it is.